Hello everyone, I am Assistant Professor Komal Shinde. In today's session, we are going to discuss about Bohr's atomic model and its application. So basically, the model of an atom which is proposed by Rutherford assumed that the atom consisting of central nucleus and electrons are revolving in a stable, much like stable orbits. Okay, so it is similar to the sun-planet system. So however, there are some fundamental difference between the two situations. Planetary system, if we consider, then that is held together by the gravitational force, and here is the nucleus electron system, means a charge object. So being a charge objects, it interacts by the Coulomb's law of force. So we know that an object which is moving in a circular orbit possesses centripetal acceleration, and according to the electromagnetic theory, an accelerating charged particle emits a radiation in the form of electromagnetic wave. So the energy of accelerating electron should therefore continuously decrease, and that electron would spin inward and eventually fall into the nucleus. Means such a atom cannot be stable. Further, according to the classical electromagnetic theory, the frequency of electromagnetic wave emitted by the revolving electron is equal to the frequency of revolution. Means as the electrons spiral inward, their angular velocities, okay, and hence their frequency also would change continuously, and so will frequency of a light emitted. Thus they could emit a continuous spectrum, but in contradiction, actually the line spectrum is, we observed, is not continuous. Okay, so it was the Niels Bohr who made a certain modification in the model by using the idea of a newly developing quantum hypothesis. So Bohr postulated that electron is allowed to occupy only certain orbits of a specific energies. Means in other words, I can say the energy of electrons are quantized. So quantize, this word is very important, because in classical mechanics we cannot imagine energy as a quantized. So first time, with the help of a quantum mechanics, we can say that energy is quantized. So an electron in any of the allowed orbit will not spiral into the nucleus, and therefore will not radiate energy. Again, Bohr proposed that the electrons do not radiate energy as they are orbit the nucleus, but exist in the state of a constant energy, which he called a stationary state. Okay, so that electron actually exists in that particular stationary states only, and while they are in a stationary states, they do not radiate any kind of energy. This means that electrons orbit at a fixed distance from the nucleus, and Bohr's work was primarily based of emission of hydrogen spectra or hydrogen atom. So I have enlisted some particles in this slide: proton, neutron with the charge, relative charge, then mass in kg, mass in atomic unit. Okay, and where they found, means proton and neutron there in the nucleus, and outside the electron is present. So after the Goldfield experiment, Rutherford proposed the planetary model of an atom, just like a solar system, but there is difference. So this model was given by Rutherford only. Okay, we have said the first and most important drawback of the Rutherford atomic model is what? Stability. Okay, so with the help of Rutherford atomic model, we cannot explain the atomic stability, and then the charge, means the radiation energy. Okay, basically we will see what is emission and so on, then we will move towards the Bohr's atomic theory. As the electrons spiral inwards, their angular velocity and frequency would change continuously, and the frequency of the energy emitted, and thus they would emit the continuous spectrum as contrast to the line spectra which we actually observed. So here white light is passing from right side, you can see the white line is passing through the prism, and on the left side you are observing the 7 colors. So here is the hot body in this figure. So this hot body is radiating radiations. if we pass this radiation to the cloud of a gas, then again through this prism, then you will observe absorption spectrum. Means some of the light is actually absorbed by this cloud of gases, and that lines are actually missing in this spectrum. Here simply if we pass the white light from the prism, it will split into the 7 colors. So this is your continuous spectra, this is your absorption line spectra. Now after some time, whatever the energy that gas cloud atoms have absorbed, it will give off, and if you pass this light to this prism, then whatever the energy they have previously observed or absorbed, they will emit it out. So this is the emission line spectra. So in a single slide I have explained what is continuous spectrum, what is absorption line spectrum, and what is emission line spectrum. So Niels Bohr, a Danish physicist, studied in Rutherford's laboratory since 1912, and he successfully explained the spectrum of hydrogen atom and presented Bohr's atomic model, and he was actually awarded Nobel Prize in 1922. So according to the Bohr's atomic model, electrons are revolved around the nucleus in a definite energy levels called orbits, or we can shell in an atom without radiating energy. As long as electrons remains in the shell, it will never gain or lose the energy. So this is the Bohr's atomic model. Then the gain or loss of energy occurs when within the orbits only due to the jumping of electrons from one energy level to another energy level. Means when electron make a transition from higher level to lower level, or lower level to higher level, there is loss or gain of energy. Okay. The angular momentum, that is mvr, of an electron is equals to integral multiple of h upon 2 pi. So angular momentum of an orbit depends upon its quantum number n and its integral multiple factor, that is h upon 2 pi. That's why here you can see mvr is equals to nh upon 2 pi, where n is equals to 1, 2, 3, 4, so on. So these are the points of Bohr atomic theory. Thank you so much.